We hope that your preparation is going well. So let's start the next video.
Hello and welcome to the BS Academy. So recently IIT Bombay has changed their syllabus a little bit to the each branches. So according to the new syllabus, we have made these charts in our best possible ways, and these charts basically give you an idea how to prepare your own charts, because ultimately you have to make your own charts of every subject, and after that you will get that confidence. So basically these charts will give you the ideas and perfect information after referring all the reference books.
This is the 8th subject for the theory of machine, in which we'll include all the syllabus of theory of machines and the concepts as well as the formulas which are important for the examination. These are the main important chapters from the theory of machines. First one is the basics, then after the flywheel, then after third one is the gear train, then after the next chapter is gear, then after the vibration, and at the end we'll discuss about the gyroscope. So let's start one by one. First one is here in the basics. As you can see that there are types of links. Before that, if you are new to your academy, then please subscribe for the coming videos and the links for the short notes which are in description box. So mainly 4 types of links are there: binary link, then after ternary link, then the third one is quaternary link, and the fourth one is profile link. Then the next topic is degree of freedom. Here for the spatial system, degree of freedom will be 6 minus r, and for the planar system, degree of freedom will be 3 minus r. Here r is equal to constraint or the arrested motions. Then the third topic is equivalent linkage. Here the equation for the degree of freedom, F is equal to 3 into n minus 1 minus 2l minus h, which is the equation for the Kurzweil's law. Then there is the conversion for higher pair to the lower pair. Here one higher pair is equal to 2 lower pair plus 1 link. And for one single slider crank mechanism, one 4-bar chain mechanism with 2 links of infinite length, you can say that. Then after the difference between the lower pair and higher pair. Here in the lower pair the surface contact is there, and the example is cylindrical pair. Then after in the higher pair, point contact or you can say that joint contact is there. And the examples are like cam and follower, then 2 gear, and the journal bearing at the slot. Then here remember that for turning pair, degree of freedom is equal to 1. Then for screw pair, F is equal to 1, and sliding pair, F is equal to 1. Similarly for the revolute joint, F is equal to 1. For cylindrical pair, F is equal to 2. And for spherical pair, F is equal to 3. These all are the basic concepts, but from these concepts also the questions were asked in the examination. So we have included this part also. Now then after, there is the Glauber's criteria. Basically Kurzweil's law with all lower pairs known as the Glauber's criteria, and the equation for that, Fm is equal to 3 into n minus 1 minus 2l minus h. Here the degree of freedom, should be 1, and it gives the information about the mobility of linkage. This question was asked in the examination, that the Glauber's criteria gives the information about the mobility of linkage. Then after moving towards the next one, which is Gyroscope's criteria. As you can see that there are 3 conditions are there. First one is if S plus L is less than P plus Q, then the linkage is Gyroscope's linkage. Then after the second one, if S plus L is greater than P plus Q, then non-Gyroscope's linkage is there. And in the third case, S plus L is equal to P plus Q, then it is known as the spatial Gyroscope's linkage. Now in the spatial Gyroscope linkage there are 3 types. First one is the parallelogram linkage. In this type of linkage, the opposite links should be same. And then after the second one is the rhombus linkage. In this type of linkage, the value of all the links should be same. Then after in the deltoid linkage, 2 types are there. In the deltoid linkage there may be the short link is fixed or in the other case the long link is fixed. But the sufficient condition for this type of linkage is the nearby value of the link should be same. Then after, this table is very useful in the examination, which is about the types of the motion as well as the type of structure and the type of chain. Here for f less than 0, the motion will be redundant motion and the mechanism will be superstructure and the type of chain will be redundant chain. Then for f is equal to 0, then there is no motion in the mechanism and the type of mechanism is structure. Then chain is locked chain. Then for f is equal to 1, here the motion is constrained motion and the mechanism is kinematic mechanism. Then the chain will be kinematic chain. Then for f greater than 1, here the motion is unconstrained motion and the mechanism is unconstrained and chain is also unconstrained. Then after, the inversion of the single slider crank mechanism. There are main 4 inversions for the single slider crank mechanism. Let's see one by one. First one is, in the first case, link 1 is fixed. Here the degree of freedom will be 1. Then here 2 cases are there. If the second link is input link, then the mechanism will be reciprocating compressor, and if the fourth link will be the input link, then the mechanism will be the reciprocating engine. And here it is the crank rocker mechanism, in which the adjacent to the shortest link should be fixed. Then after the second inversion, here you can see that in this inversion the shortest link is fixed, so it is known as the crank mechanism, or you can say the double crank mechanism. And the examples are Whitworth quick return motion mechanism and the rotary cylinder engine mechanism. Then the third inversion, as you can see here, in the third inversion the connecting rod is fixed, so the mechanism will be the crank rocker mechanism. And in this type of inversion, the adjacent to the shortest should be fixed. Here note that it is not necessary that the longest is fixed, but the adjacent to the shortest should be fixed in the crank rocker mechanism. Here, then the fourth inversion is, in which the link is fixed, and it is known as the rocker mechanism or the double rocker mechanism. In this type of mechanism, the opposite of the shortest link is fixed, and the example is hand pump. Then after, types of QRMM, here 3 types are there. First one is the Whitworth quick return motion mechanism. Then after, the crank and slotted lever quick return motion mechanism, and the third one is the offset slider crank mechanism. Then there are some equations for that. First one is for Whitworth quick return motion mechanism. There are 2 cases. In the extreme position of QRMM, here the first diagram for the end of the return stroke. Then here the equation of cos beta by 2 is equal to length of the fixed link divided by length of the crank, and stroke length is equal to C1 C2 is equal to V1 into V2 and is equal to 2 into O1 V. Then after, the second figure is for end of cutting and start of return. So the equation will be, then the equation of QRR is equal to 360 minus beta divided by beta. Here QRR is also equal to alpha upon 360 minus alpha. Then crank and slotted lever mechanism, for that the equation cos beta by 2 is equal to length of crank divided by length of fixed link, which is also equal to time during the forward stroke divided by time during the cutting stroke. The stroke length for the crank and slotted lever mechanism, SL is equal to 2 into O1 B2 into O1 A2 divided by O1 into O2. And here QRR is equal to 360 minus beta divided by beta. Then third one is for the offset slider crank mechanism. There are three equations are there. First one is sin phi 1 is equal to E by L plus R, then sin phi 2 is equal to E by L minus R, then L is equal to L plus R into cos phi 1 minus L minus R into cos phi 2, and here QRR is equal to 180 plus theta divided by 180 minus theta. Here theta is equal to phi 2 minus phi 1. So these are the equations for the QRMM. Then after the inversions for the double slider crank mechanism. Here three inversions are there. In the first one, where the slotted bar is fixed, the diagram you can see here, and the mechanism is known as the elliptical tremel. And here in this type of mechanism, the diagram will be straight line, and equation is xp square plus yp square is equal to r square. Then the second inversion is Scotch yoke mechanism. For this type also the diagram is there, and the mechanism will be the crank rocker mechanism. In this type the slider is fixed. Then in the third inversion, here the connecting rod is fixed, and you can say that the shortest link is fixed for this inversion. And the example is Oldham coupling, which is used for the linear misalignment up to the 20 to 30 mm. And for the angular misalignment, the universal coupling is used or Hooke's joint is used. Then after the next concept is the mechanical advantage. Here MA is equal to V in divided by V out, which is equal to W in by W out, which is equal to F out by F in. Then remember that this note is very useful in the examination. For the toggle position, the value of mechanical advantage will be infinite, and in the toggle position theta is equal to 180 and psi is equal to 90, then angular velocity is 0. Then after the next concept is Coriolis. It is one type of acceleration coming because of the change in the direction of the sliding velocity, and it is occurs into the Whitworth quick return motion mechanism as well as the rotary cylinder, then after oscillatory cylinder, then crank and slotted lever mechanism, Oldham coupling. From this also the questions were asked in the examination. Then after the equations for the analysis of the single slider crank mechanism. Here as you can see that the diagram is shown here. Then L is equal to N into R, and here sin beta is equal to sin theta by N. Then sin beta is also equal to sin theta into R by L. Then L into sin beta is equal to R into sin theta. Then after X is equal to R into 1 minus cos theta. Then V is equal to R omega into sin theta plus sin 2 theta divided by 2n. Then if theta is equal to 0 to 80, then V is equal to 0, and if theta is equal to pi by 2, then V is equal to R omega. Then omega CR is equal to omega into cos theta divided by under root n square minus sin square theta. Here omega CR is equal to critical angular velocity. Then omega CR is also equal to omega cos theta divided by n. Then alpha CR is equal to minus omega square sin theta into sin 2 theta divided by 2n into under root n square minus sin square theta. Here f is equal to mr omega square into sin theta, and crank radius is equal to stroke by 2. Then one more important equation for acceleration, a is equal to omega square into r into cos theta plus cos 2 theta by n. Then for the force in the connecting rod, here first is the thrust force FCR is equal to FP by cos beta, then N is equal to FCR into sin beta, and N is also equal to FP into tan beta. Then here T is equal to FT into R, then T is equal to FP into sin theta plus phi divided by cos phi into R. Then T is equal to FP by cos beta into sin phi into R. Here phi is equal to theta plus beta. Then after for radial thrust in the crankshaft bearing, TRB is equal to FCR into cos phi, and T is equal to FCR into sin phi into R. Then cos beta is equal to 2l square minus r square divided by 2l square. Then cos theta is equal to r square by 2rl. So you can say that cos theta is equal to r by 2l, and t is equal to fcr into sin phi into r. Now the next chapter is flywheel. Here as you can see that first one is the work done per cycle. W is equal to T min into theta. Then after T max minus T min is equal to I into alpha max. Then the equation for the fluctuation of speed, Cs is equal to n max minus n min by n min. Here n min is equal to n1 plus n2 by 2, which is capital N. Then after the third equation is for the coefficient of the steadiness, m is equal to 1 upon Cs. So m is equal to n upon n1 minus n2. Then fourth one is maximum fluctuation of energy, delta E is equal to 1 by 2 into I into omega 1 square minus omega 2 square. Here omega 1 is equal to maximum and omega 2 is equal to minimum. Then delta E is also equal to I into omega square mean into Cs. These all equations are very useful in the flywheel chapter. Then after the coefficient of the fluctuation of energy, C is equal to delta E max by work done. Then the next one is energy stored, E is equal to I into omega square. Then dimensions of the flywheel rim, V is equal to R omega, which is equal to under root sigma by rho. And here mass of the rim, for that mu is equal to pi into d into a into rho, and m is equal to rho into pi into d into a. Here we have considered only the important formulas from each chapter. So the next chapter is gear train. Here as you can see that there are 5 types of gear train. For the first one, which is simple gear train, the equation of train value is equal to T1 by T5, which is equal to N5 by N1, which is equal to the teeth of the driving divided by the teeth of the driven. Then speed ratio is equal to 1 upon train value. Then for the compounded gears, the equation will be same, like TV is equal to T1 by T6, which is equal to N6 by N1. Similarly for the reverted gear train, here the train value is equal to T1 into T3 by T2 into T4. Here R is equal to pitch circle radius, and you can compare R1 plus R2 is equal to R3 plus R4, as well as here m by 2 into T1 plus T2 is equal to m dash by 2 into T3 plus T4. Then for the epicyclic gear train, the degree of freedom is 2. This question was asked more than 2 to 3 times in the GATE examination, and it is used for the large speed reduction ratio. For the epicyclic gear train, the method is long, so here we have not included the equation for that. You can search out in the Google. Then after the fifth one is sun and planet gear train. For this type, if the sun is fixed, then the degree of freedom is 2, and the equation is Na divided by n capital A, which is equal to 1 upon Ts by Ta plus 1. And for the annular is fixed, then Na is equal to 0. So the equation is Na by Ns is equal to Ts by Ta divided by 1 plus Ts by Ta. These are the equations from the gear train. Then after the next chapter is gear. Here some important equations are there, which are very basics but frequently asked, like module is equal to d by t, then circular pitch is equal to pi into d by t, then diametral pitch is equal to t by d, and the multiplication of Cp into Pd is equal to pi. Then gear ratio is equal to T of gear divided by T of pinion. Then after contact ratio is equal to arc of contact divided by circular pitch, and here CR is equal to 1.2 to 1.8. Then after CR is also equal to angle of action divided by pitch angle. Then this note is very helpful, which is for the proportionality. Here as you can see that V is equal to R omega. So here omega is proportional to 1 upon R, which is proportional to the n, proportional to 1 upon train value, proportional to 1 upon gear ratio, which is proportional to 1 upon teeth, and proportional to VR, means the velocity ratio. Then after the minimum number of teeth, required for the gear or pinion to avoid the interference. Here for the pinion, T min is equal to 2 into AP divided by under root 1 plus G into G plus 2 into sin square phi minus 1. Then for the gear, T min is equal to 2 into AG divided by 1 plus 1 by G into 1 by G plus 2 into sin square phi minus 1. Then after for gear, T min is equal to 2 into AG divided by under root 1 plus 1 by G into 1 by G plus 2 into sin square phi minus 1. A, which is addendum, here A is equal to RA minus R, and the equation for RA is equal to R into under root 1 plus sin square phi into G square plus 2G. Here G is equal to R by R, here capital R for the gear and small r for pinion. Then T rec is equal to 2 into R by sin phi. Then after for conjugate profile, there are two types, involute profile and the cycloid profile. In the involute profile, phi remains constant and this profile is generated by nature. And in the cycloidal profile, phi changes and it is made by the hobbing process. Then after law of gearing, the diagram you can see here, and the law states that the line of action always passes from the fixed point, which is called the pitch point. Then omega 2 divided by omega 1 is equal to O1p divided by O2p, which is equal to O1m divided by O2n is equal to constant. Then here the length of path of contact is equal to KL, which is equal to KP plus PL. And the equation of KL is equal to under root RS square minus R into cos phi square minus R sin phi plus under root small r square minus r cos phi square minus small r into sin phi. Here in the second term you have to use for the small r. Then here in this diagram, KL is equal to O to O1, then KP is equal to from O2 to P, and for PL, which is the arc of recess, the value will be O1 into P. Now the next chapter is vibration. So from the vibration chapter, each and every equations are most important for the examination. So you can take a screenshot if you want. Now let's begin one by one. First one is here the general differential equation of motion, me into x double dot plus c into x dot plus k into x is equal to fe. Here me into x dot for the equivalent mass or equivalent inertia. Then c into x dot is equal to equivalent damping. Then k into x is equal to equivalent spring stiffness, and f is equal to external force. Here for free or natural vibration f is equal to 0, and for forced vibration f is not equal to 0. Then after fn is equal to 1 upon 2 pi under root k by me, which is in hertz, or you can say that cycle per second. Then after t is equal to 2 pi under root me by ke, and omega n is equal to under root ke by me. Then omega n is equal to 2 pi f. These all are basic equations, but you have to just go through it once. Then after for the series and parallel connections, here for the series 1 upon k is equal to 1 upon k1 plus 1 upon k2, and for the parallel k is equal to k1 plus k2. So here this proportionality you can remember that for k proportional to c proportional to I proportional to 1 upon r will be remain same as the equation of the k, and for r you can inverse the equation. Then after I naught is equal to ml square, and omega n is equal to under root g by l. Then t is equal to 2 pi under root l by g. Then omega n is equal to under root kt by I, which is for without mass of shaft. Then with consideration of mass of shaft, the equation will be omega n is equal to under root kt divided by I plus is by 3. And then after some important values of the inertia, here for the ring it is mr square, then I for disk is equal to mr square by 2, then I of sphere, which is solid sphere, then 2 by 5 into mr square, then for solid cylinder mr square by 2, then I of rod is equal to ml square by 12, then iosphere which is hollow, then 2 by 3 into mr square. So these terms you have to remember because these values may be not given in the examination. And here for the disk type of problems, here one note there, as you can see that while calculating the examples you have to keep this in mind that in consideration of inertia of disk, here the value is the 3 by 2 into mr square. Generally we take the value of mr square by 2, but in this type of figure you have to consider that the mr square value for the distance of bottom to the center. So here the value of I is 3 by 2 into mr square. You have to take care about the inertia value in any example. Now mainly from the vibration, here 4 types of questions were asked. First one is the spring and damper, the second one is lever type, and the third one is circular disc type, and the fourth one is pulley type. So we have discussed the equation of the spring and damper in the terms of under root kt by I and under root g by L. Here the second type is for the lever based questions. In that there are 2 types are there. First one is the vertical type problems and the second one is horizontal type problems. So you have to just remember this one equation, and based on this you can solve any example of the lever based questions. Here the standard differential equation of motion is sigma mi li square into theta double dot plus sigma ci into bi square into theta dot plus in bracket sigma ki into a square plus sigma kt plus or minus sigma mi into g into li into theta is equal to 0. Here similarly for the horizontal type of questions, you have to neglect the value of mg into L and the remaining equation will be same. So this is very simple equation, and based on which you can calculate any examples. Then after you have to just use the equation of omega n and f for finding the frequency or the angular velocities. And if there is the case for the combination of vertical and horizontal problems, then you can solve it by considering the problem as the horizontal type problem. That means you have to neglect the value of mg into L. Then after for the free vibration and force vibration, the most important equations are there. Let's see one by one. For the free vibration, the critical damping coefficient Cc is equal to 2 into under root mk. Then zeta is equal to damping factor, which is equal to c by 2 into m omega n, and zeta is equal to c by cc. Then td is equal to tp by omega d. Then after c by 2m is equal to zeta into omega n, then lambda 12 is equal to omega n in bracket minus zeta plus or minus under root zeta square minus 1. Here if zeta greater than 1, then overdamped system is there, and if zeta is equal to 1, then critically damped system is there, and if zeta less than 1, then underdamped system is there. Then c omega by k is equal to 2 into zeta into q. Here q is equal to omega by omega n. And for the force vibration, there are main 3 equations are there. First one is the response x is equal to a into cos omega t minus phi. Here the equation of a, which is amplitude, a is equal to f naught by k divided by under root 1 minus q square whole bracket square plus 2 zeta q whole bracket square. Here mf is equal to magnification factor, and value of mf is equal to 1 upon delta st. Here delta st is equal to f naught by k. The next concept is transmissibility ratio. Epsilon is equal to ft by fo, which is equal to under root 1 plus 2 zeta q square divided by under root 1 minus q square plus 2 zeta q square. Here f naught is equal to external force and ft is equal to transmitted force. So here the value of f naught you can calculate it from the equation of the amplitude. Here the value of q is less than or equal to root 2, then zeta is lower and epsilon will be higher. Then for q is equal to root 2, epsilon is equal to 1, and for q is greater than root 2, then zeta is lower and epsilon is also lower, which is less than 1. So this is the best condition for any system or any mechanism. And here for q greater than root 2, mf is also less than 1, which is magnification factor. Then one more note is there. At resonance q is equal to, at resonance q is equal to 1, which is equal to omega by omega n, and mf is equal to 1 upon 2 zeta. Then a is equal to f naught divided by 2 into k into zeta. Then some more notes are there. Omega is equal to omega n into L square. This equation you can use in the exam. Here, as you can see in the example, if the figure is given like this, then there are two temporary nodes are there, and here one loop is equal to number of temporary nodes plus 1. So you can put the values of L in the equation and you will get the angular velocity based on the natural angular velocity. Then after omega n is equal to omega by 4 for the effective isolation, and omega n is equal to omega by 4 for the effective isolation, and q should greater than root 2. Then here one more note is there. For the critical speed of shaft, the equation of y is equal to e by 1 by q square minus 1. Then after the methods used for deriving the differential equation of motion, two methods are there. First one is the equilibrium or the Newton's second law. For that, the equation will be mx double dot plus kx is equal to 0, and the second one is the energy method. Then after some key elements table is there, which is very basics but useful, the linear motion as well as the angular motion, then for the spring and in the damper. So these are the notation which are used in the different type of systems. You can take a screenshot if you want. Then after response analysis, for that some equations are also there. First one is for free vibration of undamped system. Similarly, there are equations, you can take a screenshot. After that, for the free vibration, response of the damped system is also there. The equation will be x is equal to a into e raised to lambda t. Here the governing equation is m into lambda square plus c lambda plus ka is equal to 0. Then the last topic of the vibration, which is the logarithmic decrement ratio. Here the equation of delta is equal to 1 upon n into ln x naught by xn. Here x naught by xn is equal to e raised to n delta. Then after there is one example for the logarithmic decrement ratio. So this is all about the vibration chapter. Now there are two tables for the cam and followers. These tables are important. From this table, the equations of Vmax and Max may be asked in the examination. So for the uniform velocity, Vmax is equal to h into omega by phi a, and there is no acceleration there. Then after for SHM means simple harmonic motion, Vmax is equal to h into pi into omega by 2 phi a, and mx is equal to pi square into h into omega square divided by 2 into phi a square. Then for the cycloidal motion, 2 into h into omega by phi a, and mx is equal to 2 into pi into h omega square divided by phi a square. Here the diagrams are also there for the values of v is equal to velocity, a is equal to acceleration, and j is equal to jerk. Then here Vmax for the cycloidal motion is greater than that of the simple harmonic motion, which is greater than the uniform velocity motion. Then during rise period, dy by d theta is positive and phi will decrease, and during return dy by d theta is negative, phi will increase. Then tan phi is equal to dy by d theta divided by rb plus rr plus y, and for the offset cam, tan phi is equal to dy by d theta minus e divided by under root pi b square minus e square plus y. So these are some important equations from the cam and follower. Now the last chapter of the theory of machines, quick revision, is gyroscope. Here in the gyroscope, first one is the definition. For the pitching, it is the motion about the transverse axis. Then for rolling it is the motion about the longitudinal axis, and in the steering it is the motion about the height. You can see the diagram for the respective definitions. Then after some notations for the ship, here the front part is known as the bow, then the rear part is known as the stern, then the right side of the ship is known as the starboard, and the left side is known as the port. These notation are also important in the examination. Then after the equation for the gyroscopic torque or gyroscopic couple, T is equal to I into omega s into omega p, where alpha is equal to omega s into omega p, omega s for the angular velocity of axis of spin, and omega p is equal to angular velocity about the axis of precision. Here alpha is equal to angular acceleration. Then the most important topic from the gyroscope is the effect on the aeroplane or the ship. So if we go with the traditional method, then it is more confusing for so many students. So we have developed one short note here that you just need to remember only one line, which is positive lane downward. It means that here L for left side you have to take the negative, here A is equal to anti-clockwise, for that you have to take the negative. So here N is equal to negative. Then if the resultant is positive, then nose goes down. You just need to remember that positive lane goes down. After reading it one or two times, you can remember it very easily, and based on this, now you can take any example, like if first one is the direction of the taking turn of plane is left side, and the direction of rotor is rotating in the counterclockwise or anti-clockwise, then for that also the negative and the resultant of two negatives are the positive, so the gyroscopic couple will be positive. And as we have said, you have to take the result that the effect is nose goes down and the tail goes up. Similarly for the right side and the clockwise, the resultant will be positive, and you can check any other cases there. So this note will be very useful in the examination, that the positive lane goes down. So we hope that you like this trick also, and you like this video, because all the important concepts and the important formulas we have covered in the short video of the theory of machines. So if you like this video, please do like and subscribe to the BS Academy, and press the bell icon for the upcoming quick revisions for the different subjects of mechanical engineering. If you like this video, please share it to the other students who is preparing for the GATE examination. Thank you so much.